Okay, so first of all, this was pretty consistent. Component form of our vector PQ was, I saw a lot of people have -1, 5, right? Okay, Callie, explain to me how you got -1, 5.
I took -6 plus 5 because you take the, you subtract the first number,
Okay,
and then 8 minus 3.
okay, so terminal minus initial, we get the components -1 and 5. Okay, the magnitude of PQ. Keegan, what did you get there? And how do you get radical 26?
That's the a squared plus b squared.
Good.
The radical
Good. So vertical component squared plus horizontal component squared all under the radical. It's like the Pythagorean theorem, right? Okay, I'm going to skip down to linear combination form. Okay, Caleb, what's the linear combination form?
-I plus 5i.
Okay, -I plus 5j. Remember, I is the vector 1, 0, j is the vector 0, 1. Okay, what I am having issues with is our direction angle. We have a variety of answers. Now, we're pretty consistent in the fact that we need to take the tangent of theta equals b over a, right? Well, what happens when you take the inverse tangent of -5? -78 points, what? Okay. Now, is that the angle for the vector -1, 5? No, -1, 5 lies in which quadrant? Second quadrant. So we need a second quadrant angle. Okay? 78.69 is your reference angle. I would even ignore the negative. The negative doesn't matter. The 78.69 is your reference angle. Okay? So if we want to be in the second quadrant, then we would need to take 180 minus 78.69 to get 101.31, right? That's our angle. Okay, so we're still going to be in section 6.3. Okay. But what we're going to talk about is we're going to talk about taking a vector and writing it in either form, but in terms of its magnitude and direction. Okay. So up here I have a vector b. I have labeled our direction angle and I have labeled its magnitude. Okay. What I'm going to go ahead and write out is that this vector, I'm going to call it the vector AB. If that's the case, then we know that if we make a triangle, this side would be length A and this side would be length B. Do you agree with that? Vector AB. We go over A, up or down B to draw our vector, right? On Thursday, we discussed using tangent, right? Well, what if we use like sine and cosine? Okay, I want you to think of the sine and cosine ratios. Our cosine ratio. Eli, what is it? Our sine ratio. Marissa, what's our sine ratio? So if I wanted to write A and B in terms of the magnitude and direction, then we can just solve these ratios here, okay? A is the same thing as the magnitude times the cosine of theta. B would be the same thing as the magnitude times the sine of theta. So instead of writing our vector as A comma B, we could write it as magnitude times the cosine of theta, magnitude times the sine of theta. I'm also going to write linear combination form up here. If you want to write it down, you can, but it's the same concept. Horizontal component is magnitude times cosine of theta. Vertical component is magnitude times the sine of theta. Okay? And that's just coming from our trig ratios that we wrote up here. Okay? Why is it helpful to know that? Okay? I could give you a vector in terms of its magnitude and direction. And if I want the component form, we would need to use these ratios to figure out the component form. So I have two examples for us that deal with putting a vector into component form. All right, we'll start off nice and simple. Some unit circle values here. Okay, so first example, I have a magnitude of 2 and I have a direction angle of 45 degrees. Okay, well if I want vector v, okay, to get our horizontal component, we need to take 2 times the cosine of the angle. And if I want the vertical component, we're going to take 2 times the sine of the angle. Okay? This is something that we can get exact values for, right? The cosine of 45 degrees, everybody, what is it? Radical 2 over 2. The sine of 45 degrees, what is it? Radical 2 over 2. So vector v is radical 2, comma, radical 2. Okay, now we can imagine what that vector looks like, right? We probably could pretty easily with 2 and 45 degrees, but here's the component form. Okay. The separate components will be helpful when we get into applications of vectors here in like 10 minutes or so. Okay, so that one was pretty straightforward. This next example has a little bit of a twist. I'm giving you that vector v has length 3, okay, its magnitude is 3, and I don't give you the angle, I just tell you that it's in the direction of negative 3i plus 4j. So before we can put this into component form, what do we need to do with negative 3i plus 4j? We need a direction. Okay? So I'm going to give you about 60 seconds to find the angle, the direction angle of negative 3i plus 4j, and then compare it to your neighbors. Grace, what do you have for the direction angle?
126, 23.
And what did you do to get that?
From 4 over -3.
Okay, and that gave you negative 53.13, right? Okay, remember that's a reference angle. I wouldn't even worry about the negative, to be honest. We know that this is in the second quadrant, so 180 minus our reference angle of 53.13 gives us an angle of 126.87 degrees. Okay.
No,
Oh,
I didn't.
a good question.
No, it's not a good question.
Okay, fair enough. Thank you for fielding that. Okay, so now if we want vector v, we can take our magnitude times the cosine of our angle, 126.87 degrees. And for our vertical component, our magnitude times the sine of 126.87 degrees. Okay, so go ahead and find those components for me. Lindsay, what do you have? Negative 1.8 and 2.4. Love it. All right. Next, we're going to put another twist on it. Now I'm giving you the magnitude and direction of two vectors, vector v and vector u. And I am asking for the component form of the sum. Okay, so write down the information that you need. Find the component form of the sum. Okay, so what do you think our process is going to be? Okay, can I add these two together right now? We cannot. Okay, we cannot add these two together yet. We first need the component forms so we can add like components together, and then we will have the component form of u plus v. Okay, so we need to find the component form of u, and then we need to find the component form of v. So pods 1, 2, and 3, please work on the component form for u, and pods 4, 5, and 6, please work on the component form for v. You have 60 seconds. I will tell you that both of those angles are unit circle values, so I expect nice numbers with no decimals. Grace F., what do you have for you?
2
2 and 2 radical 3. Pause 1, 2, and 3. How do you feel about that? Have some thumbs up. Great. Vector V. Kira, what do you have for that? 0, 5. Pause 4, 5, and 6. How do you feel about that? Okay, we have our individual vectors in component form. Now we can find U plus V. 2 plus 0 and 2 radical 3 plus 5. Okay, we can't actually add those two numbers together because one's irrational and one is rational. So we just have to write it as 2 radical 3 plus 5, but that's okay. All right, let's get into some application. Okay, if you have taken or are taking a physics class, a little bit of physical science, any work you've done with vectors, you've done more with the application. Okay, vectors can help us with force. Okay, so a vector's magnitude is going to describe a force applied. Okay, so forces with magnitudes 2,900 newtons act on a machine parts at angles of 30 and negative 45 degrees respectively. Find the direction and magnitude of the resultant of these forces. Okay, so what's happening is we have two vectors acting together. And when you see the word resultant, what operation is that referring to? Okay, we're adding these two vectors together. These two vectors are working together on this machine part. So we're going to add them together. Okay? 2,000 newtons and 900 newtons, that would be the vector's magnitude. Okay? When we have a force, that's describing the magnitude of the vector. Okay? So first goal is we need to get the resultant of these vectors. Let's jump back to our simple example over here. I'll go back. We had magnitude, direction, magnitude, direction. We found the component form and then added them together. So let's do the same thing here. Okay? Let's say that vector U is the vector that has 2,000 newtons and an angle of 30 degrees. And then I'll say vector V is our vector with magnitude 900, angle of negative 45 degrees. So I'll let you write down what you need to if you need to catch up. I got kind of excited there, so if you need to back up and write any information down, please go for it. So this would be my suggestion. 30 degrees and 45 degrees, those are angles from the unit circle. Okay? The more exact we can be early on in our work, the more accurate our answer is going to be when we get to the end. Okay? So I would write this as, so this is 2,000 times radical 3 over 2. So I'm going to write 1,000 radical 3. And then this is 2,000 times 1/2. This is 900 times radical 2 over 2. And then this is 900 times negative radical 2 over 2. So our resultant vector, and it's not going to be pretty, but it is what it is. Our horizontal component is 1000 radical 3 plus 450 radical 2. And then our vertical component is 1000 minus 450 radical 2. Okay. Now, that's what our vector is, but I am asking you for the direction and magnitude of the resultant. Okay? Yeah, that's the vector, but how much force is really being applied on that machine part as a result of these two vectors? And at what angle is that force being applied at? Okay? That's going to make more sense than this vector here. Okay? So what I'm going to have you do is in your calculator for me, I want to show you a trick on your calculator. You like learning new tricks, right? Okay, and I may have shown you this trick before. I honestly can't remember. But let's put in 1000 radical 3 plus 450 radical 2. I know that I'm going to have to use that number for both our direction and our magnitude. Okay, so yeah, I'm going to write down that it's 2,368.45. But what I'm going to do is I'm going to store it. Do you see the store button right here? Have I showed you this? Okay. Do you see all these green letters? Okay. If I press store alpha A, that means anytime I press alpha A, it's going to give me that number without me having to rewrite it. The letters are not for writing fun messages. They can be used for that, but not their main purpose. Okay? Here's store. We'll do it again. So 1000 minus 450 radical 2 is this number. Who cares? 63.60. But I'm going to, right here, store it in alpha B. Okay, so now I have the vector AB. Okay, so now when I go to find the angle, I know the tangent of theta is B over A. So I can just say, all right, let me check my phone. Inverse tangent of alpha B divided by alpha A is, boom, 8.723 degrees. Okay. And if we want the magnitude, then we know we need to take the square root of A squared plus B squared. Yeah.
Store button. On the side of the store. And then whatever variable you want to assign it to. Just click on it. Can you hear that?
Okay, so help me out because I'm going to have to move my calculator. Our magnitude was 2,396.19. And since our magnitudes up here were labeled as newtons, we would want to label that as newtons. So two vectors acting together on a machine part, even though separately they have forces of 2,000 newtons and 900 newtons, when they act together, they're really putting a force of 2,396 newtons at an 8-degree angle. And that's what's really happening. We have time for one more example. Okay, a slingshot. All right. Slingshot is fired at a velocity of 30 feet per second at an angle of 20 degrees. So I would at least write velocity of 30 feet per second, angle of 20. So you at least know what's going on when you look back at your notes. And that's my rock that I'm slingshotting, okay? So it is shot at a 20-degree angle with a velocity of 30 feet per second, okay? 30 feet per second. What did that just give us about our vector? It gave us our magnitude, okay? What I'm asking for are the vertical and horizontal components of velocity. Okay, so basically I'm asking you for A and I'm asking you for B. Okay, if I want the horizontal component of velocity, okay, we're just going to do the same thing we've been doing. We're going to take the magnitude times the cosine of the angle. Isn't it nice that anything that deals with horizontal deals with cosine? Anything that we do vertical deals with sine. Okay, it's going to be like that, no matter what. Okay. When we take 30 times cosine of 20, what do we get? 28.19 feet per second. Let me put this in perspective for you. If you are lying on the ground and somebody was shooting that slingshot, you would only see that slingshot moving horizontally 28.19 degrees. That's what you would see. Okay? If you were lying down and just looking at it from the horizontal. Okay? Vertical. Okay? We want this vertical component of velocity. All we have to do is take the magnitude times the sine of the angle. Okay? If you're standing right in front of the person with a slingshot, which I hope you would not be, because you might get going with that rock that they're shooting. But if you were, okay, you would only see that vertical change at 10.26 feet per second. But in reality, that thing's coming at 30 feet per second. Okay, but you'd only see that vertical change at 10 feet per second. Okay. All right, just in time. We have a book assignment this evening. Correct? Where's our book? Okay. You have a book assignment, same thing. I give you a short assignment and I'm requiring you to do all of them because there's a variety of problems. And so Miss Cronky and I picked the ones that mean the most. It's not a long assignment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Shorter than last time. I guess I can call it last time. Okay? Tomorrow we'll do the dot products. If you did not turn in your quiz corrections, they are considered late, but give them to me for some credit. 0 credit.